So today let's take a look at this Generac RS5500 generator. This generator belongs to a friend at work, Todd, and it's only got 21.9 hours on it. And this generator is coming from the shop saying that it has an open stator winding. I blurred out some of the information here, but this is the actual receipt stating that it needs alternator assembly, the whole rotor and stator assembly, and the correct regulator not feasible to repair. They said they looked around the unit, verifying damage prior. Started the generator up to verify fault. Wasn't putting out power. Took the covers off so I could access the rotor and stator. The unit has wrong regulator. I do know Todd replaced the regulator with a different type to see if it would help after it already quit working. So it needs to have the right regulator because the aftermarket, so that's probably why they're saying that. And check the rotor. It's good. Tested the stator and it's open, so have to order a new rotor and stator assembly to fix it. So the question is, can it be fixed? So just for nothing else but fault finding, let's take a 7mm and let's take the cover off and see. I did expect the repair shop to at least put it back the way it was when I received it, but evidently they left everything unhooked. We just want to test the windings here first anyway. So the stator windings, I'm on the red trying to find the right neutral, and there we go, 0.6, 0.7 ohms. Good. Let's go to black, go to the other one. Yeah, 0.6, 0.7 ohms. The actual stator output windings look good, and they said the rotor was good, but the brush assembly has been removed. So that looks good. Let's move on to the other windings. See this flex here, it just goes up to the outlet panel where the breakers and the outlets are, and this other connector has two blue, a white, and a green, and this goes to our AVR or automatic voltage regulator module. I'm going to have to look up some information on this, but just right off here, going across the two blues, and that's not looking pretty. We open white and green. I'm not sure, but I would think you would have something on white and green and on the two blues. So that might be the part of the stator that actually had issues. Not sure at this point. Let me get you in here so we could see the actual slip rings on the rotor. Get on here, make contact, and yeah, right at 63 ohms. That should be good. And the slip rings look good. We definitely have to investigate these windings here to make sure I'm checking them correctly. So one big shout out here to Generator Magic. So I did a lot of searching to try to find information on the RS5500 generator head. Could not find any chart or ohms reference. Definitely was looking for the repair manual or service manual. Most places want you to buy the manual. Generator Magic is the only place I found after looking for quite some time that lets you download it for free. So just showing here, in case it helps you, you can go to the page, just click on the link that lets you the free download. Of course, you can buy the hard copy if you want it shipped, but I thought that was really good of them to have it there and so easy to find and so readily available for us to be able to look up here on this model. And just looking at the configuration here, even though ours is not wired exactly like this because we don't even have the 4 poles on the right for the stator windings to go to, we do see our C1 female plug, and we definitely show that 2 and 6 is your blue, your DPE or your displaced phase excitation coil, and then you have your AVR sensing, which is white and green. Looking on further down in the manual, we did find the rotor and stator resistance table, which was very handy. Find our RS5500 and rotor windings. That was great. We well within the 10% of that one. The power windings on the stator, dead on. When it gets to exciter winding, that should be the DPE, the blue wires. So we definitely have something going on with our DPE windings. Going to cut this tie wrap up here to remove some of this cabling and get it out of the way. Looks like a 14mm here on our vibration dampeners. These are 10mm here for the muffler and bracket. We're just going to take time here to show some disassembly. We start looking into the problem at about minute 8 if you're interested in that. I definitely had to remove this one or remove the ground wire from the other spot. I'm not sure if it's better to remove the top or the bottom on these vibration dampeners at this time. Either way, I probably got to loosen up the bottom as well. I'm going to remove the 4 bolts. These are 10mm that go through this end housing or end bell into the front housing that holds the stator onto the rotor. And I'm going to have to remove the muffler. The little swivel socket does help here get into the tight spot. Could also remove the gas tank and help as well. There we go. Get my bolt and fill the gasket. The gasket actually feels pretty good. I think we're safe to reuse it. If not, they're a little metallic gasket. It's fairly cheap. Go ahead and remove this bracket, or at least slide it out of the way. And we can remove our 4th bolt. I'll go ahead and just take this bracket off. This is just a dust cover or inspection cover that I had taken off just to look and see if the windings were dark earlier before the video started. Just getting it out of the way. Now these bolts on the bottom here are 13mm. Get it off the ground a little and pull these off. Pull it up. I do have this supported with some wood blocks now. I might have to change the way that is. And by the way, I did take a silver Sharpie and mark on the right side lineup marks. Even though it's only one way this can really go, still just to be on the safe side, I did mark it. Now I could use a 2-jaw puller that I have to try to pull this end bell and stator assembly off of the bearing. I don't want to put too much pressure on this small aluminum casting, so I'm just going to try to tap it gently with my rubber mallet and a block of wood, and it's definitely moving slow and easy. And there we go, our stator's off just that quick. I do not see any dark windings on this stator. We'll look at it closer in just a minute. So here's our rotor. It looks good and it owned really good. I'm just going to prop this back up with another smaller piece of wood. Just to show here, these are our magnets that do the like the residual magnetizing of the fields. What helps the generator start up when it first starts spinning and puts out a little voltage before it gets excited. And by the way, just to mention for safety, you definitely want to unplug or remove your spark plug before you rotate any of this, because if it did start up, it could be catastrophic. So back now on the bench, let's look at this a little bit closer. We're going to focus more on our blue wires because I still don't have any information on the white and green other than they call them an AVR, automatic voltage regulator winding. Definitely open. And I got my little fine probes here. These are not good for low ohm readings, but they are good to get in places and make sure there's no corrosion and be able to pierce in the insulation if we need to. But just to show you what I was looking at outside earlier, these windings do look good. They almost look a little flattened out, but I believe they did that at the factory because the rotor fan, the cooling fan is there, and I think they just make those flattened out just so it's no way the fan can come in contact with them. That would destroy them pretty quick. When you see windings burn up, usually it's a telltale sign. They're very dark. The varnish is dark. All these windings look in light new condition, really. Just a little over 21 hours on it, so not a lot of use. By the way, these 2 nuts here are showing where the bolts go through from the end bell through the stator. I'm going to go remove this end bell or end housing, and I'll be right back so we can look at this a little closer. So I'm going to take some of the dullest point cutters that I have and start cutting some of these tie wraps as well as some of the lacing. And of course this lacing, if you're not familiar, it has a lot of varnish on it. So sometimes you'll hear a snap from cutting a tie wrap, and sometimes it's just that lacing. It snaps and cuts about the same way because it's hard. So I simply just want to cut against the cloth insulation or sleeve. I'm not going to touch any of the windings with the metal tool at all. Just want to lift up these sleeves here and hopefully just verify connections on these windings, and at that point there's probably nothing more that we can do. Alright, so there we go. We pull this sleeve off, and this is one of our winding connections, and here I feel like I may have broke this connection because I did pull on it. I was just pulling to make sure it wasn't a bad connection. I didn't think it had a thermal, but I wasn't even sure it wasn't a thermal in here, so I'm just checking to see how they did these windings on the stator. But I didn't pull on this very hard. It did pull off. Now it looks like I did break it So I'm not going to get too excited about that yet. Like it was making a connection to me. If we follow this side of our DPE winding down that was hooked to the blue wire, we do see that it goes down here on the bottom, right at 7 o'clock position or so, and it goes in. Nothing looks like it's rubbed or touching, nothing's discolored. So I really don't know why we have an open winding here, especially if it's supposed to be 3 ohms. We shouldn't be reading open. Going to go ahead and slit this sleeve so we can get to the wire and look at it a little bit better. It looks like it's still tinned on the end. I'm not sure about that, but let's go all the way back to the other blue wire, whichever one it is, I'm not sure. But nope, definitely not reading any ohms there either. So I went ahead and cut the ties and the lacing on this other side of the DPE winding. And sure enough, when I went to pull this apart, I didn't even get it on camera, but it actually did pull apart just as easy, if not easier, than the other winding connection. So let's trim this one back and see if we can get lucky here, but not looking good at this point. They look tinned on the ends. I'm not 100% sure, but still open. That's just reading through my body. Nothing showed there. It's all mega ohms, but I am going to take time to strip off some varnish and just make sure that I'm getting a really good connection on our laminated wire. Wait, what? Going to go ahead and scrape this varnish back even further to make sure I get a good connection. I would love to see something in the ohms reading here. Let's get out of the mega ohms. Yes. Did we just get lucky? Yep, I saw it as low as 30 ohms, and these leads do not make a good connection. I'll bring over some different leads in just a minute. Just going to cut these sleeves back. Going to go ahead and put some flux on here and tin these wires. I'm just going to put a good bit of solder on here so it's easier to tin the windings when I put those wires on there as well. Don't want to forget my larger sleeve in here. And let's see how well this will solder. I'm not going to twist these much at all. With my smooth jaw pliers, I'm barely gripping enough just to turn it on the tip. I do know that these windings are very, very delicate. Put some more flux on here. I still got some solder on my tip here. Let's see if we can't get this to puddle up. Now this is a 70-watt iron, and it should be plenty hot enough to do this job, but I can see that it is struggling. I can try to get out my 200-watt iron. I can also try to get just a torch out and do open flame, but typically the soldering iron itself will burn off a lot of that varnish, but even though I scraped it, it's not doing the best. It did stick, but it's not pretty. I'm just going to bring over some non-insulated butt connectors. I have a Dyson hairdryer video where I showed using these, and I had already cut some with a Dremel into shorter lengths of butt connectors. I'm just going to use these like so and just slide them on there and just crimp them on there for good measure. These are soft. They're coated copper, so they're soft enough that I trust them that they don't mess up the winding too bad. I'm going to get some of the solder off of this other blue wire because I had a good bit on there. Get my braid and pull some off. I'm going to go ahead and gently wrap this around, and we'll crimp this one as well. And just as a side note here, I did go back and redo this one. I don't think I got it on video. I didn't like the way that I'd done this one with the winding going in at the angle and putting pressure on the winding when I pushed down on it. So I just made them go like in line, facing each other. I don't mind making the blue wire, the MTW stranded wire, I don't mind making it bend. I didn't want to make that little thin copper winding wire bend that much. So it probably would have held, but I went ahead and redone it. So other than that, I ended up with it being just like it is. If I bring up on my meter with the other leads, just under 3 ohms. I'm excited about that. We may have just saved this generator. I'm going to take time here to look at the green and white wire for the AVR. These definitely have 2 winding wires instead of the single like the DPE. And I'm just going to scrape back the varnish and just make sure the reading isn't different. Like I might need to reconnect these as well. But no matter what I do, they show open. So here I'm just going to verify that where I have them scraped on the winding, they do go all the way up to the connector. And I verify that they do. I have a good connection all the way back. So I'm just simply going to put some Kapton tape over these and just let these fly, because I have no information on what this is supposed to be, and maybe they don't list it because it's such a high reading. But if anybody else understands or has more information about the AVR winding, please leave it in the comments below. Just taping up with some Kapton tape here and pushing the sleeve over. And after the Kapton tape and pushing the sleeves over, just one more quick check here before we tie wrap it up. Awesome. I'm just going to use some thin tie wraps here to put this back. I don't even have any lacing to put back on here, but I think these small tie wraps are going to do just fine. I am going to cut some of this lacing and tie wrap out. Anything that's stuck in the varnish, I'm not pulling on it. I'm just going to leave it. I don't want to interrupt where the varnish is adhered to the windings, but if it's sticking down, I'm just going to trim it off. Got our tie wraps all tightened down nice and snug. Hopefully nothing will move with these winding connections. We'll trim these off. We'll double check it one more time before we install it. Awesome. So still not exactly sure about the white and the green wire here for the AVR. If anyone has more information on that, please leave it in the comments below. At the time of this video, I can't find any information on what the resistance should be of those windings. We're going to put this back on and test it out. Slide our stator on. Then we'll put on our end bell. Just got to get our wires through here, and these 2 long screws go here. 7mm fits these bolts here. And we have to put this together before we slide the stator fully on, because the little nuts go on the back of the laminations for the stator. Those same little nuts I showed on the bench earlier. Just get this all trued up. We'll tighten it up a little bit. Make sure our mark is lined up on the right side that I marked earlier. And there we go. We'll slide our stator on, and we're in place. I'm just going to use my mallet to try to keep this square and mate it up. Put our 4 bolts back in to secure our stator. I did forget to put the ground wire back on. Let's secure that. There we go. We'll put our bracket back on for our muffler. I'm gonna go ahead and put the muffler back on. I didn't really get much footage of putting the other bolts in the muffler, but I did show them coming out earlier. I'm gonna go ahead and put the brush assembly in. I didn't actually remove this, but it was in the bag of parts. It looks in good condition. It just goes like so. It's got a little stud that sticks out on the right, and then you line it up and push it on in one bolt. As far as the AVR, I'm going to put the original back on, but this is both of them. The colors don't quite match up on the plug. It might be fine, I don't know, but I'm going to put the original one on and go from there. At this point, I'm assuming the winding failure happened first before he tried to put the new AVR board on. I want to mention this part of the video, there might be some reassembly here that's not done exactly right. I think I showed on video, but I received this, all the wiring off of it, so I am putting this back the way I think it goes, and then looking at the drawings and things and what I think should be. I did not have anything to go by when I first got this to know that I'm 100% right. But I do see our plus here on our brush holder. Let's go ahead and plug it up. The red's got the plus identifier on the wire. As you can see at the top of the brush holder, it says plus, and we got a minus on the one closer to me. So we're going to hook it up like so. I see no reason for that to be wrong. We had to plug this P1 connector up, which shouldn't be a problem at all. I feel good about that. We'll get our power wires in here, and I do have a new zip tie that's secured here with an eyelet. I'm going to remove this screw that's loose here that says ground. I'm going to connect all the neutrals and the ground together, because looking at this drawing from the manual that we shared earlier, it does actually show only 2 spots, and we only have 2 studs for power. And then it does show that all the neutrals and grounds are bonded. So I'm going to assume they're bonded at that point. We're going to put our red to red and our black to black on our terminal block. And that looks right to me. This is 8mm. This is what we look like before we're going back to test. Go ahead and put our cover on. Again, 7mm here. We're definitely going to check the oil in it, even though it just came from the shop. We're going to verify that it's good, and that's good to go. We're going to go over to start. How easy is this going to be to start? Well, it definitely tried. I guess I'll pull it one more time and choke or start. There we go. Awesome. The motor runs very good. 248 volts. No load. That's awesome. One leg of the 120. We're getting right at 124. Go to the other leg. Right at 124. Awesome. I'm just going to go ahead and check the receptacles. It's the same winding, just going to make sure the receptacles are good and the breakers are good. 124, awesome. And yeah, 124, awesome. Back now, we're going to put it under a load. I do have a kilowatt here. If we can see the display, I'll try to get a little closer in just a minute so you can see it better. But halogen lights on. We're going to cut the heater on. That should be over 1,000 watts. Well, let's see. I'm not getting the wattage I'm expecting here. I think the cord has got the safety switch lifted up. There we go. I heard the generator load down some. Yeah, we got over 1,000 watts there and climbing. We should be at about 1,300 watts. I also have a hammer drill. It's rated up to 11 amps. So we should be about maxing out this one circuit. Put it under a load here and test it well. Yeah, about 1,500 watts and hit the button, and yeah, we over 2,200 watts. So we're really close to 20 amps on that. There we go. See 13 amps and yeah, 20, 19. Go back to volts. The volts look good. Regulation is very good and the speed's great. 59.7.8 hertz. Awesome. Here's a little up close to that display in case it was hard to see on camera. Running at 13 amps. Over 1,500 watts. I'll hit the hammer drill and yeah, over 2,200 watts. Right at 119 volts. Unplug it, remove all the load, shut it down. Awesome. So with a little bit of effort and a lot of luck, we were able to save this Generac from seeing the junkyard today. I hope Todd gets a lot more life out of this generator, and hopefully this video will help somebody else that might be having the same issue. I don't know how common this issue is, but I knew it was a shame to have a generator so new to have an open stator on it. So just thought it was worth looking into a little bit deeper today. Please leave a comment down below if you by chance have a generator that had the same issue. So I hope you found this video helpful. If you did, please like, share, and subscribe. I'm going to have some links down in the video description of some tools and things that I like to use on my workbench, and as well as tools I use today. A lot of those links are affiliate links, and any link you click on helps support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.